Okay, so we need to, in this problem, find the dimensions of an open rectangular box of maximum volume, so that's what we're trying to maximize here, that can be made from a sheet of cardboard 13 inches by 8 inches by cutting congruent squares from the corners and folding up the sides. Okay, so you have a big piece of cardboard, 13 by 18 it says. Okay, so that's that big side is 13 inches and the short side is 8 inches. So now if we cut congruent squares, so we're cutting from each corner, so it would look kind of like this. Cut a little square out, 4 squares of the same size. I don't know exactly how big those squares are, that's what we're trying to figure out. Okay, so if you were to cut those squares out and then you folded up the sides, so you put a fold right there and you'd fold this side up, so this is like a bird's eye view of the box. You fold that side up, this side up, and this side up, and you just throw away these corners, those are just gone, right? Then this is the base of the box, and that's one side, another side, another side, and another side, and it's an open top, which it does say an open rectangular box, so I guess that means the top is open. Okay, so we need a variable here, or variables, because we're not given any, so we get to choose. So we want to maximize volume. Okay, volume is length times width times height. There's kind of like, I guess there's hard ways and easy ways to define variables here. Probably what I would do, if you let this be the variable, it's difficult because then how do you describe it, right? You know it's related to 8 and the size of the corners, but how do you write that? If you let that be the variable, I think it would be easier to let the length of each side of the squares that you cut out be your variable. Like, so if we call that x, well, these are all 4 squares, so that's also x. That's x. That's x, and that's true on all 4 corners. Okay. All of those little distances are x. And then it becomes a little bit easier to write the dimensions of the box. Okay, let me draw the box, kind of more of a bird's eye view. So there's the long side. This is the base there. Okay, that's that base. So this side, if we take out x and x from that and that, so then what we're left with, like if this whole length is 13, we're trying to find this length in terms of x. Okay, so this length would be 13 minus, if I can write sideways here, 13 minus x that we cut away, so minus 2x. That corresponds to that right there, 13 minus 2x. Okay, then this is, let's do a different color here. So then we're folding up those pieces. So when we actually fold up the box, those pink corners become the sides, like these 2 corners right here get taped together or glued together or something. So those corners, the pink parts look like that, and then it's an open top. Okay, so that, all those little pink lines, right, have length x. Okay, and I think from that you can figure out how to put the other side of the box also in terms of x, right here. And if you do it this way, then everything's in terms of x, and you actually don't even need a constraint, which is nice. So hopefully that helps. We can work some more of this problem if anyone needs help with it after this point, but hopefully that gets you set up